The edge of space is closer to you than the next city over. Not light years away, not some distant frontier out among the stars, but a little over 100 kilometers straight up, a distance you could drive in about an hour if the road turned toward the sky. And the moment you crossed that line, everything your body depends on would be gone. The air would leave your lungs in an instant. The moisture on your tongue would begin to boil. You would have 9 seconds of clear thought, maybe 15 before the dark took you, and in those seconds the most hostile place human beings have ever found would not even be trying to kill you. It would simply not be arranged to keep you alive. That is where this begins, only just over your head, and it grows stranger and colder and more frightening at every single step we take away from home. So get comfortable and settle in. If you're new here, hit subscribe and stay a while, because by the end of tonight the darkness above the sky will feel less like empty space and more like something quietly watching back. Now, let's slowly ease into this. Part 1. The line above your head. Space is not a distant place. This is the first thing to understand, and it is the thing almost no one truly believes, because everything about the way we talk about space encourages us to imagine it as somewhere far away, somewhere you would have to travel toward for a very long time before you arrived. The truth is stranger and much closer than that. If you could turn your car to face straight upward and drive at highway speed, you would cross into space in about an hour. The boundary that separates the world you live in from the most hostile environment human beings have ever encountered sits only about 100 kilometers over your head. That is roughly 62 miles. It is a shorter distance than the one between many people and the city where they were born. We tend to picture the sky as a thing with real substance, a soft blue ceiling that holds the world in. It is not that at all. The layer of air that keeps you alive is astonishingly thin, thinner than almost anyone guesses. About half of the entire mass of the atmosphere sits below an altitude of only 5.5 kilometers, which is lower than the summit of the tallest mountains. Climb higher than that and already half the air is beneath you. Keep going and the atmosphere thins toward nothing, long before you reach that boundary 100 kilometers up. If you shrank the Earth to the size of an apple, the entire breathable atmosphere would be thinner than the apple's skin. Everything you have ever breathed, every cloud you have ever watched, every bird and every airplane and every weather system that has ever passed over your head, all of it happens inside a film so delicate that it barely registers against the size of the planet. Above that film, there is no gentle transition into somewhere else. There is simply the beginning of a place where none of the rules your body depends on continue to apply. And the first thing that place would do to an unprotected human being is not what most people imagine. We have all seen the version in films where a person exposed to the vacuum swells and bursts in an instant, or freezes solid, or explodes in some dramatic and merciful flash. None of that is what actually happens, and the reality is quieter and, in its own way, far more disquieting. If you were exposed to the vacuum of space with no protection, you would not burst. Your skin is strong enough to hold you together against the modest pressure difference. What would happen instead is that you would have somewhere between 9 and 15 seconds of useful consciousness. During those seconds you would still be awake, still aware, still able to think and to move. The problem is that the oxygen already in your bloodstream would be all you had left, and once your body circulated that oxygen to your brain, and it was used up, there would be no more coming. You would drift into unconsciousness without pain and without warning, the way a person falls asleep without meaning to. Before that, though, something else would begin. The water in your body would start to respond to the absence of pressure around it. At the temperature your tissues hold, water in a vacuum wants to turn to vapor, and so the moisture in your skin and in the soft parts of your body would begin, gently, to boil. This has a name. It is called ebulism, and it is not theoretical. In 1966, a technician named Jim LeBlanc was inside a vacuum chamber at a NASA facility, testing a spacesuit, when a hose failed and his suit lost pressure. He was exposed to a near vacuum for a short time before the chamber could be repressurized and he was rescued. He survived, and he was able to describe what those seconds were like. The last thing he remembered feeling, before he lost consciousness, was the saliva on his tongue beginning to bubble and boil in his mouth. That detail is worth sitting with for a moment, because it tells you something about the character of the place we're about to travel into. It did not kill him instantly. It did not do anything violent or theatrical. It simply began, quietly and without any malice at all, to take a human body apart according to the ordinary laws of physics, because those laws do not include any provision for keeping a person alive. That is the recurring truth of everything that follows. Nothing out there is trying to hurt you. It is simply that nothing out there is arranged in your favour, and the absence of that arrangement is enough. Consider the temperature, because here too the intuition most people carry is wrong. We say space is cold, and we picture something like the coldest night imaginable, a freezing that would take you quickly. But cold, as your skin understands it, requires something to carry the heat away from your body, and in a vacuum there is almost nothing to do the carrying. Heat moves mainly through contact and through the movement of air, and in space there is no air to move. So the danger becomes a strange and split thing. On the side of you facing the sun, with sunlight falling directly and nothing to disperse it, a surface can climb well above 100 degrees Celsius, hot enough to cook. On the side turned away in shadow, that same surface can fall below -100 degrees, cold enough to shatter. There is no comfortable middle. An object in space is not simply cold. It is scorching and freezing at the same time, in the same moment, separated only by which way it happens to be facing. You begin to see the shape of the thing. The world we live on is a narrow band of tolerable conditions held in place by an almost impossibly thin shell of air, and that shell is the only reason any of the frightening things we're going to talk about remain, for now safely at a distance. Take the shell away and the nearest edge of the most extreme environment we know of is not light years off. It is directly above you, right now, closer than the horizon. There is a phrase worth introducing here, because we are going to return to it more than once as we go, and it will mean something different each time. The idea is this: the farther out you travel, the more the darkness stops being empty and starts being a presence. At this first threshold, only 100 kilometers up, the darkness is still mostly an absence, a lack of air and warmth and pressure. But even here, at the very shallowest edge of the journey, you can feel the beginning of the change. The dark above the sky is not simply the place where the air runs out. It is the first hint of something that has been waiting above us the entire time, patient and enormous and indifferent, held back only by that thin blue film we so rarely think about. Most of us live our whole lives without ever once looking up and understanding what we are actually looking at. We see the blue and we read it as safety, as a lid, as the comfortable top of the world. What we are really seeing is the last thin margin before everything changes. The blue is not the sky's true colour. It is sunlight scattered by the molecules of air, bounced and rebounced until the whole dome glows. It is a trick of the light performed by the very substance that keeps us breathing, and it is the only thing standing between the ordinary afternoon and the beginning of the void. If you have ever stood outside on a clear day and felt the sun on your face and thought nothing of it, you are standing at the bottom of an ocean of air, looking up through the only part of the universe that has ever been kind to us. Everything above that, everything past the point where the blue fades to black, is a place that will not keep you alive for the length of a held breath. And that place begins not at some unreachable distance, but at an altitude a commercial jet climbs halfway toward on an ordinary flight. This is where the journey starts then. Not out among the stars, not at the edge of the galaxy, but here, just over your head, at the line where the air gives out. It is the gentlest threshold we will cross tonight, the one closest to home, the one that still bears some faint resemblance to a place a person could imagine surviving. And already, at this first and shallowest step, the rules have changed completely. Already the environment has become one that would take a human being apart in seconds, calmly, by no more than the ordinary operation of physics. There is a threshold on the way up that most people have never heard of, and it makes the point better than almost anything else. It is called the Armstrong limit, and it sits at an altitude of only about 19 kilometers, roughly 62,000 feet, well within the range that some aircraft can reach. At that height, the air pressure has dropped so low that water boils at the temperature of the human body. This means that above the Armstrong limit, the moisture in your eyes, in your mouth, in your lungs, and in your saliva will begin to boil away even though your body is at its normal warmth. You do not need to reach the edge of space 100 kilometers up to meet conditions that will kill you in this strange and specific way. You only need to climb about 19 kilometers, a distance some balloons have crossed, and already the inside of your own body wants to turn to vapor. Pilots who fly that high wear pressure suits not against the cold, but against the boiling, because without them their blood would froth in their veins. The atmosphere we live under is not one thing, but a series of thin layers stacked on top of one another, and each one is stranger and less hospitable than the last. The lowest layer, the troposphere, is where all our weather happens, where the clouds form and the rain falls, and it reaches up only about 10 kilometers before it ends. Above it lies the stratosphere, thin and dry and still, where the ozone that shields us from the worst of the sun's radiation is concentrated in a layer so diffuse that if you gathered it into a single sheet at the pressure we breathe, it would be only a few millimeters thick. A few millimeters of gas is all that stands between the surface of the Earth and a flood of ultraviolet radiation that would sterilize the land. Above the stratosphere the air grows thinner still, through the mesosphere and beyond, until there is nothing left to breathe and nothing left to burn the falling meteors that streak the night, and the layers give way to the open dark. The pioneers who first tried to reach these heights paid for the knowledge with their lives. Early balloonists ascending in open baskets in the 1800s climbed higher than the body can tolerate and lost consciousness without understanding why, some of them dying in the thin air miles above a world that looked peaceful and small beneath them. They had no way to know that the sky they were rising into was not a gentle ocean, but a thinning poison, that every kilometre upward stripped away another portion of the pressure and the oxygen their bodies silently required. They discovered the ceiling of survivable air the only way it could be discovered, by rising until they could rise no more, and some of them never came back down alive. And the higher you go, even before the air fully gives out, the more the shielding fails. Down here at the surface, the thick blanket of atmosphere absorbs most of the radiation that pours in constantly from the sun and from far outside the solar system. Climb towards space, and that blanket thins beneath you, and the radiation rises, so that the crews of high-altitude aircraft and the astronauts above them absorb far more cosmic radiation than anyone on the ground. The same thin shell that gives us air to breathe is also the shield that holds back an invisible sleet of high-energy particles that would, over time, damage every living cell exposed to it. We do not merely live at the bottom of an ocean of air. We live behind a wall we cannot see, and the wall is thinner than we ever imagine, and everything that wall holds back is waiting on the other side of a boundary we could drive to in an afternoon. Hold on to that feeling of nearness, because we are about to leave it behind. Everything from here forward moves outward, and at each new threshold the fear will change its shape into something the previous one could not have prepared you for. What waits just a little higher, in the black sky that hangs over the daylit world, is a kind of permanence that the surface of the earth has never once shown us. Above the thin blue shell, something is always true that is never true down here, and once you understand what it is, you will never look at a clear afternoon in quite the same way again. Part 2. The Night That Never Ends. Rise a little higher, past the line where the air gives out, and you arrive at the altitude where human beings actually live in space right now, tonight, as you listen. The International Space Station orbits the Earth at about 400 kilometers up, and there are people aboard it at this very moment, circling the planet at a speed that is almost impossible to hold in the mind. They are moving at roughly 28,000 kilometers per hour. At that speed, they complete an entire orbit of the Earth about once every 90 minutes. This means the astronauts aboard the station watch the sun rise and set not once a day, as we do, but around 16 times in every 24 hours. 16 dawns, 16 dusks, a sunrise every 45 minutes, each one lasting only seconds, the Terminator line racing across the curve of the planet below them faster than any storm. And here, at this altitude, you meet the first fact about space that changes something permanent in the way you see the sky. Above the atmosphere, the sky is black even at noon. There is no blue up there, not because it is night, but because there is no air left to scatter the sunlight into that soft glowing dome we live beneath. The sun still shines fiercely, a hard white disk far brighter and more violent than it ever appears from the ground. But around it, in every direction, there is only black. An astronaut in direct blazing sunlight, with the full unfiltered force of the sun on their visor, looks up and sees not a bright sky but a black one, scattered with stars that do not twinkle because there is no air to make them shimmer. This is worth saying plainly, because it is one of those facts that quietly rearranges your sense of where you live. Down here, we think of the black sky as belonging to night, as the thing that arrives when the sun goes away. Up there, Only 400 kilometers overhead, the black sky and the blazing sun exist together at the same time in the same glance. Above the blue, it is always night. The daylight we know, the bright and gentle blue of an ordinary afternoon, is not a property of the sun or of space at all. It is a thing our thin shell of air manufactures for us, a local comfort, painted freshly every morning on the underside of the atmosphere. Rise above the paint and the truth is waiting, and the truth is that the daytime sky is an illusion, and the real colour over our heads, always and everywhere, is the black of permanent night. There is something in that fact that unsettles people more than they expect. It is not dangerous in the way the vacuum is dangerous. Nothing about a black noon sky will hurt you, and yet it reveals that one of the most basic and reassuring features of the world, the bright blue day, is a thing so fragile that it exists only in the last few kilometers of air, and that just above it the universe has been sitting in darkness the entire time, at every hour, on every clear afternoon you have ever enjoyed. The night was never something that arrived. It was always there, directly overhead, waiting behind the light. Now, at this altitude, there is a second fact, and it is the first sign that the emptiness ahead is not entirely empty. We have already begun to fill this region, the near space just above our heads, with the wreckage of our own machines. In the decades since we first started launching things into orbit, we have left behind an enormous quantity of debris. There are roughly 30,000 pieces large enough to be tracked from the ground, each one catalogued and followed because each one is a potential weapon. And below that, too small to track but far more numerous, there are millions of fragments, flecks of paint, shards of metal, frozen droplets of old fuel, each one travelling at that same orbital speed of many kilometers per second. At those speeds, size stops mattering in the way it does on the ground. A fleck of paint no bigger than a grain of sand moving at orbital velocity carries enough energy to crack the reinforced window of a spacecraft. A bolt the size of a fingertip hits with the force of a hand grenade. The astronauts aboard the station have had to shelter, more than once, as tracked debris passed close enough to threaten the hull. And there is a darker possibility hanging over all of it, an idea named after the scientist Donald Kessler, who first described it. If enough objects collide up there, each collision produces a spray of new fragments, and each of those fragments can go on to strike something else, producing still more fragments, in a cascade that feeds on itself. The Kessler syndrome, as it is called, describes a runaway chain reaction of collisions that could, in the worst case, wrap the Earth in a shell of shrapnel so dense that we would no longer be able to safely leave the planet at all. We could, in principle, wall ourselves in with our own garbage and lose the sky. Sit for a moment with what that means. The very first region above our heads, the shallowest layer of the ocean we're only beginning to swim into, is already a place we have made more dangerous by our presence, not less. The terror of space, we are about to learn, is mostly a terror of absence and distance and indifference. But here, at the very start, before any of that, is a smaller and more human fear, which is that even in the one small pocket of space we have actually reached, we have already left a mess that could trap us. Imagine now that you're up here yourself. You're outside a spacecraft, high above the Earth, the planet a curve of blue and white beneath you, and above and around you the black sky with its hard, unblinking stars. The sun is up. It should be day, and yet the sky is night, and the silence is total, because there is no air to carry a single sound. You reach up to the seal of your helmet, and in this imagining you break it. The air leaves you at once, pulled out into the nothing, and with it goes every sound you have ever known, so that even the rush of your own breath is gone. Your ears ring with a silence more complete than any you have felt, the silence of a place where sound itself cannot exist. You feel the moisture on your lips and on your tongue begin to fizz and lift away as it turns to vapour in the vacuum. The cold has not reached you yet because there is nothing to carry it, and for a strange suspended moment you are simply floating, awake, aware, in the blazing black daylight, watching the blue curve of your home planet turn slowly beneath your feet. You have perhaps 9 seconds of clear thought. You spend the first of them realizing that the world you come from is right there, close enough to see every cloud, and that it might as well be 1,000 light years away, because the few hundred kilometers of empty height between you and it are already too much for a body to survive. The darkness has stopped being merely empty. Up here, wrapped around you, pressing the air out of your lungs. It has become a presence. Pull back from that. Return to yourself, in the warmth, in the air, on the ground. That is the second threshold, only 400 kilometers up, and already the sky has revealed that its daylight is a lie, and its emptiness is not as empty as we hoped. We have littered the shallows, and even the shallows will not let us breathe. But this is still, by an enormous margin, the most familiar and forgiving place we will visit. From here we can still see home filling half the sky. We can still make out continents and weather and the lights of cities on the night side. It is worth staying up here a little longer, because the speed of this place is as hard to grasp as its darkness, and the two together produce the danger. 28,000 kilometers per hour is difficult to feel as a number, so consider what it does. At that velocity, an object crosses the length of an entire country in a matter of minutes. It means that the astronauts aboard the station are not drifting lazily above the world. They are hurtling around it faster than any bullet, fast enough that the only reason they do not fall back to Earth is that the ground curves away beneath them just as quickly as they fall toward it. Orbit is not the absence of falling. Orbit is falling so fast and moving sideways so quickly that you keep missing the planet. Every person who has ever been in orbit has been, in the most literal sense, falling continuously, plunging toward the Earth forever and never once arriving, held in a perpetual controlled plummet that we have learned to call floating. Now put that speed together with the debris, and you understand why the danger is so acute. Two objects in orbit do not drift gently toward one another. They meet at a combined speed that can approach 50,000 kilometers per hour, and at that velocity the ordinary rules of hardness and softness stop applying. A small screw, a lost tool, a frozen droplet of coolant hitting at that speed delivers more energy than a hand grenade. This is not hypothetical. Spacecraft windows have been chipped and cracked by paint flecks. Panels have been punched through by fragments too small to have been tracked. The astronauts who live up there practice the procedures for a sudden loss of pressure, for the moment when something they never saw coming opens a hole in the wall between them and the vacuum, because the region they inhabit is filling year by year with the fast-moving debris of everything we have ever launched and abandoned. Consider how quickly we fill this region, because the speed of it says something about us. The first artificial object was placed in orbit only in 1957, a small metal sphere that circled the Earth and beeped, and it stayed up for a matter of months before falling back and burning in the air. That was well within a single human lifetime ago. In the decades since, we have launched thousands upon thousands of satellites, rockets and probes, and the broken remains of most of them are still up there, circling, because in the near vacuum of low orbit there is almost nothing to slow them down and bring them home. The wreckage does not fall quickly. Much of it will remain in orbit for years, for decades, for centuries, crossing and recrossing the paths of everything else we send up, a growing cloud of fast metal that we added to the sky in the span of a few generations. We reached the edge of space, and almost the first thing we did there was leave our garbage in it, and now that garbage is one of the main hazards facing anyone who follows us up. There is a particular loneliness to the view from up there that the astronauts themselves have tried to describe and mostly failed, because words are not built for it. They speak of seeing the entire Earth at once, the whole of it, every ocean and continent and every place where every human being who has ever lived was born and died, hanging in the black small enough to cover with a thumb. And they speak of the thinness of the atmosphere seen edge on, a faint blue line hugging the curve of the planet, so delicate that it looks as though a breath could blow it away. Many of them come back changed, having seen for themselves the thing we have only described, that everything we are, everything we have ever done, is contained in a thin film of air on a small ball of rock, surrounded on every side by a black and airless immensity that begins only a few hundred kilometers up and does not stop for the rest of forever. That is about to end. The next threshold takes us away from the Earth entirely, to the nearest other world we have, the one body in all the heavens that human beings have actually stood upon. And when we get there, we'll find that even our closest neighbour, the friendliest and most reachable destination in this entire descent, is a place where none of the things that make a world feel like home have ever existed at all. Part 3. The Dead Neighbour. The moon hangs so familiarly in our sky, so soft and silver and constant, that it is easy to think of it as gentle. It is the light we walk home under, the face in the window, the oldest companion our species has ever known. Every human being who has ever lived has looked up and seen the same moon, and something about that shared, unchanging presence makes it feel almost like a part of the Earth, a second and quieter half of home. It is not. It is the first genuinely alien world in this journey, and the distance to it is the first distance in our descent that begins to break the imagination. The moon sits, on average, about 384,000 kilometers away. That number is hard to feel, so here is a way to hold it. If you took every other planet in the entire solar system, Mercury and Venus and Mars, Jupiter and Saturn, Uranus and Neptune, and lined them up side by side, all 7 of them, you could fit the whole row into the gap between the Earth and the Moon, with room left over. The space between us and our nearest neighbour, the little silver disk that looks close enough to touch, is wide enough to swallow every other world that orbits our Sun, and that is only the first step past our own planet. That is the shortest interplanetary distance there is. When you arrive, you find a place that has none of the things a world is supposed to have. There is no air. This is not a matter of thin air or bad air. There is essentially no atmosphere at all, which means there is no sound. If you stood on the moon and shouted or struck 2 stones together or fired a rocket engine beside you, you would hear nothing, because there is no medium for the sound to travel through. The silence of the moon is not the quiet of a still night. It is an absolute, total absence of sound, a silence that has never once in billions of years been broken by anything but the faint vibrations carried through the rock itself. There is no wind, because there is no air to move. There is no weather. There are no clouds, no rain, no seasons in any sense we would recognize. The sky above the lunar surface is black at all times, day and night alike. For the same reason the sky was black over the space station. There is no air to scatter the sunlight into blue. Even in the full blaze of the lunar day, with the sun burning overhead, the skies are starless black, because the sunlight on the bright ground washes the stars from view without a blue dome ever forming. The days and nights themselves are not like ours. Because of the slow way the moon turns, a single lunar day and a single lunar night each last about 14 Earth days. Imagine 2 weeks of continuous, unbroken sunlight, the sun crawling across that black sky so slowly it barely seems to move, and then 2 weeks of continuous, unbroken night, a darkness that settles in and does not lift for the length of half a month. During the long day, with the sun beating down and no air to spread or soften the heat, the surface climbs to around 127 degrees Celsius, hot enough to boil water many times over. During the long night, with no atmosphere to hold any warmth, that same ground plunges to about minus 173 degrees Celsius. The same patch of dust that scorched at noon becomes cold enough 2 weeks later to freeze the breath from a body instantly. There is no gentle evening in between, no cooling dusk. There is only the extreme, and then the other extreme swinging back and forth across a gap of 300 degrees. And there is a stranger thing still about the moon, which is that it keeps one face turned toward us at all times, and the other turned permanently away. Over the long ages, the pull of the Earth has slowed the moon's spin until it turns exactly once for every orbit it makes, so that the same side always faces home. This is why we, on Earth, have looked at the same lunar face for all of human history, the same seas and craters, the same patient expression, never once seeing the other side without sending a machine to look for us. The far side of the moon faces out, away from the Earth, into the open dark. And that fact carries with it one of the loneliest images in the entire solar system. If you were to stand on the far side of the moon, on the hemisphere that faces permanently away from us, you would never see the Earth. Not at the horizon, not overhead, not at any hour of the long day or the long night. The blue marble that fills the sky of the near side, the home that Apollo astronauts photographed hanging over the grey plains, would simply not be there. You could stand on that far surface for a lifetime, turning in every direction, and the sky would offer you nothing but stars and the sun and the black between them. Home would be beneath your feet, on the other side of a world, forever hidden by the body of the moon itself. There are places in this solar system, not light years away, but a mere 3 days' travel from where you sit, where the Earth has never risen and never will. Here too we meet an idea that is going to grow larger and stranger every time we return to it. When you look at the moon from Earth, you are not seeing it as it is. You are seeing it as it was. Light takes a little over 1¼ seconds to travel from the moon to your eye. It is a small delay, almost nothing, but it is real. The moon you see tonight is the moon of 1¼ seconds ago, and that means something quietly profound, which we're going to carry with us all the way to the end of this journey. When you look out into space, you are always looking at something that is already gone. You never see the sky as it is now. You only ever see it as it used to be, each point of light showing you a different moment in the past, none of them the present. With the moon, the delay is barely more than a heartbeat. But the farther out we go, the longer that delay becomes, until at last it stretches into millions and then billions of years, and the light reaching your eye will have left objects that have since changed beyond recognition, or moved, or died, or ceased entirely to exist. The moon is where that truth first appears, gentle and small, a delay of 1 second and a quarter. Remember it. It will not stay small. Think then about what the moon really is. It is the closest world to our own. It is the only other ground that human beings have ever stood upon. It is the friendliest, nearest, most reachable destination in this entire descent into space, the one place beyond Earth that we have actually visited with our own bodies and returned from alive. And it is a silent, airless, sunburnt, frozen expanse of grey dust where a lunar night lasts 2 weeks, where the temperature swings through 300 degrees, where sound has never existed, and where, on half of its surface, the Earth has never once appeared in the sky. This is the gentle option. This is the good neighbour. Consider what it actually took for human beings to survive there even briefly. The astronauts who walked on the moon did not step out into a neutral emptiness. They stepped into an environment that was actively trying, by simple physics, to end them, and only the suit kept the 2 weeks of extremes at bay for the few hours they stayed. The lunar surface is covered in a fine grey dust called regolith, ground out of the rock over billions of years by the endless rain of tiny meteorites that strike a world with no air to burn them up. That dust is not like sand. It has never been weathered by water or wind, so every particle is sharp and jagged, and it clings to everything, working its way into seals and joints and fabric, scratching visors, wearing through the outer layers of the suits. The astronauts found that it smelled faintly of gunpowder when they brought it back inside, and that it was so abrasive it could have worn their equipment to failure had they stayed much longer. The moon does not need weather or predators to be hostile. Its very soil is a hazard, sharpened by the same bombardment that, on any longer visit, would eventually reach the visitors themselves, and that bombardment never stops. Without an atmosphere to shield it, the lunar surface is struck continuously by micrometeorites, tiny grains of rock and metal falling in from space at tens of thousands of kilometers per hour, each one hitting the ground with nothing to slow it. On Earth, these same particles burn up harmlessly in the upper air, and we see them as shooting stars. On the moon, they arrive at full speed and strike the surface directly, so that anyone standing there is exposed at all times to a faint sleet of high-velocity impacts, any one of which could, if it struck a suit, open it to the vacuum. Add to that the radiation, pouring in from the sun and from the wider galaxy, with no magnetic field and no atmosphere to turn it aside, and the long lunar night, 14 days of darkness in which the temperature falls low enough to freeze equipment solid, and you begin to understand that the friendliest destination beyond Earth is friendly only in the sense that we can reach it at all. It offers nothing else. It offers no air, no warmth, no shelter, no mercy. It is a place we can touch, and that is the only kindness it has. The strangest part is how beautiful it looks from here. This same moon that would kill an unprotected visitor in the length of a held breath is the soft silver light we have written poems to for as long as we have had language, the gentle face that has watched over every night of human history. There is a lesson in that gap between how it looks and what it is, and the lesson runs through this whole journey. The things in space are often lovely from a distance and lethal up close, and the loveliness is not a lie exactly, but it is a comfort we project onto a place that has no comfort in it. The moon is beautiful. The moon is also a silent, airless, sunburnt, frozen expanse where the Earth never rises on half its surface. Both of those are true, and the distance between them is the distance this whole descent keeps crossing. Everything from here gets less forgiving, and it gets less forgiving quickly. Because the moon, for all its desolation, is still practically in our backyard. It is close enough that we can see it plainly, close enough that the light delay is barely a second, close enough that we have walked there and come home. The next threshold does something the moon does not. It takes the small, survivable distances we have been dealing with and multiplies them until they stop making sense, until the very concept of distance begins to feel like a kind of cruelty. When we step out past the moon and into the true body of the solar system, we're going to discover just how much nothing there really is between the worlds, and how alone a traveller out there would truly be. Part 4. The Emptiness Between Worlds. Once you leave the moon behind, the friendly distances end, and the real scale of the solar system begins to open beneath you like a floor giving way. To understand what happens next, you have to first understand the unit that astronomers use to measure distances out here, because it is a number that quietly resets everything. The distance from the Earth to the Sun is called 1 astronomical unit, and it is about 150 million kilometres. That is the baseline, the single step, the smallest ruler we use when we talk about the solar system, and even that first step is larger than the mind can truly picture. Light, which is the fastest thing that exists, moving at a speed that could circle the Earth more than 7 times in a single second, takes 8 minutes and 20 seconds to cross that distance. Sit with that for a moment, because it hides another appearance of the truth we met on the moon. The sun you see in the sky is 8 minutes and 20 seconds old. The light warming your face left the surface of the sun more than 8 minutes ago, and crossed 150 million kilometres of empty space to reach you. If the sun were to somehow vanish in an instant, you would not know for over 8 minutes. You would go on feeling its warmth, seeing its light, living your ordinary afternoon, while the star that anchors your entire world had already ceased to be. Once again, you are always looking at something that is already gone. The delay that was barely a second at the moon has become more than 8 minutes at the sun, and we have not yet even left the inner solar system. Now let the distances grow. The Earth orbits at 1 astronomical unit. But the solar system does not end anywhere near there. Move outward past Mars, past the asteroid belt, past Jupiter with its storms wider than our whole planet, past Saturn and its rings, out to the cold blue world of Neptune, and you find yourself at about 30 astronomical units from the Sun. 30 times the Earth's distance. That is roughly 4.5 billion kilometres. Out there, light from the Sun takes about 4 hours to arrive, and from the surface of Neptune, or from a ship floating in its orbit, the Sun would no longer be the great dominating fire that rules our sky. It would be a single very bright star among the others, a point of light you could blot out with a raised thumb, casting a pale and distant glow across a world where noon is dimmer than twilight on Earth. The Sun, the centre of everything, the source of all our warmth and light, shrunk to a spark. And Neptune is not the edge. It is only the last of the major planets. Beyond it lies a whole further realm of icy bodies, and beyond that the true frontier where the sun's influence finally fades. To understand how far that frontier really is, consider the fastest and farthest traveller our species has ever launched. In 1977, we sent a small spacecraft called Voyager 1 out toward the outer planets. It flew past Jupiter and Saturn, sending back images that changed how we saw our own neighbourhood, and then it kept going, outward, faster than any object we had ever released. It has been travelling now for nearly half a century, moving at about 61,000 kilometres per hour, never stopping, never slowing. In 2012, after 35 years of flight, it finally crossed the boundary called the heliopause, the place where the sun's outflowing wind gives way to the thin gas between the stars, at a distance of about 121 astronomical units. It had, at last, entered interstellar space. And here is the number that should make you go quiet. After nearly 50 years of unbroken flight, after becoming the most distant human-made object in existence, Voyager 1 is only about 1 light day from home. 1 day, if you were travelling at the speed of light. The fastest thing we have ever built, moving outward for almost half a century, has covered a distance that light itself crosses in 24 hours. That is the size of the gap we're dealing with now. Not the width of a planet, not the reach to the moon, not even the 8-minute span to the sun, but a distance so wide that our greatest feat of exploration, sustained across 2 human generations, amounts to a single day at light speed. Even that does not mark the sun's true edge. Far beyond Voyager, far beyond the planets and the icy fields past Neptune, there is thought to be an immense shell of comets surrounding the entire solar system, called the Oort cloud. It is the reservoir from which long-period comets fall inward toward the Sun, and it marks the outermost boundary of the Sun's gravitational reach. No one has ever seen it directly. We infer it from the comets that come from it. But the estimates of its extent are staggering. The Oort cloud may begin a few thousand astronomical units out and stretch to as much as 100,000 astronomical units from the Sun. 100,000 times the Earth's distance. That reaches nearly a full light-year outward, which means the Sun's true domain, the sphere within which its gravity still holds sway, extends almost halfway to the nearest other star. Our solar system, properly understood, is not the tidy diagram of planets we drew as children. It is a nearly empty sphere almost 2 light-years across, with a handful of tiny worlds huddled near the warm centre and an enormous dark shell of frozen comets marking its distant invisible rim. And this is the fear that arrives at this threshold, replacing the fears that came before. On the Moon, the terror was environmental, the airlessness, the cold, the silence. Here, the terror becomes something new. It is the terror of distance itself, of emptiness so wide that help becomes impossible and rescue becomes a fantasy. A traveller stranded between the planets is not a few hours from safety. They are months or years from the nearest other human being, floating in a volume of space so large and so empty that the planets themselves are little more than specks scattered through an immensity of nothing. The space between the worlds is not dotted with way stations and islands. It is very nearly perfect emptiness, a near-total vacuum broken only rarely by a lonely wanderer of rock or ice. If something went wrong out there, no one could reach you in time. No one could reach you at all. We have a habit of drawing the solar system as a crowded, busy place. All the planets close together, the Sun looming large, everything within easy reach. That picture is a lie of scale, and it is a comforting one, because the truth is almost unbearable to render honestly. If you shrank the Sun to the size of a marble and placed it on a table, the Earth would be a nearly invisible grain of dust about a metre away, and Neptune would be another fainter grain some 30 metres off, and the edge of the Oort cloud would be kilometres distant, out past the walls of the building, out past the town. The solar system is mostly, overwhelmingly, almost entirely empty. The worlds are the rarest things in it. The nothing is the rule, and the somethings are the exceptions. There is a famous image that captures this emptiness better than any diagram, and it was made almost by accident. In 1990, as the Voyager 1 spacecraft was leaving the solar system, having passed the outer planets, the astronomer Carl Sagan urged that the cameras be turned around for one last look homeward. From about 6 billion kilometres away, the spacecraft took a photograph of the Earth, and in that image our entire world appears as a single point of light less than a pixel across, a tiny pale dot suspended in a band of scattered sunlight, almost lost in the emptiness. Everyone who has ever lived, every king and every child, every war and every love, all of it, on that one nearly invisible speck. And that photograph was taken from only 6 billion kilometres out, barely the beginning of the journey, not even a full light day from home. From the true edge of the Sun's domain, the Earth would not show up at all. It would be too small and too faint to find, drowned in the glare of a sun that had itself shrunk to a bright star. The films have taught us to imagine the spaces between the planets as busy and dangerous, especially the asteroid belt, which is usually shown as a churning field of tumbling rocks so densely packed that a ship must weave frantically to avoid being crushed. The reality is almost the opposite, and it is more unsettling than the fiction. The asteroid belt is real, and it contains a great many objects, but it is spread across such an enormous volume of space that the average distance between one asteroid and the next is hundreds of thousands or even millions of kilometres. If you were standing on one asteroid, you would very likely not be able to see another one at all with the naked eye. Spacecraft have flown through the belt many times, and the danger of collision is so small that it barely factors into the planning. The belt is not crowded. It is nearly empty, like everything else out here, a scattering of rare rocks lost in an immensity of nothing. Even the one place in the solar system we imagine as densely packed turns out, on inspection, to be mostly void. And the emptiness between the planets is not passive. The space a traveller would cross is filled with radiation, an invisible and constant hazard that our atmosphere and magnetic field shield us from completely down here. Beyond that protection, the Sun throws out storms of charged particles, and from far outside the solar system comes a steady rain of cosmic rays, high-energy fragments of atoms moving at nearly the speed of light. A human crew crossing to Mars, a journey of many months, would absorb a dose of radiation that mounts steadily the entire way, with no shelter and no shield, every day of the trip adding to the total. The emptiness between the worlds is not merely wide and cold and lonely. It is also quietly, invisibly toxic, so that even the act of crossing it exposes the traveller to a slow and constant harm that the thin blue shell back home had been silently absorbing for them their whole lives. So we have crossed only the first light day of our journey, and already the distances have grown teeth. Already the fear has changed from what would happen to your body into how far you are from everything you know. And yet, and this is the part that should make the skin prickle, we have not gone anywhere at all. We have not left the sun's own backyard. Everything we have described, the planets, the comets, Voyager's half-century of flight, all of it fits inside the reach of a single star. The next threshold takes us past that reach entirely, out to where the sun becomes just another point of light behind us, and the true gulf, the one that dwarfs everything we have seen so far, finally opens ahead. Because if the solar system is a lonely place, the space between the stars is a loneliness of an entirely different order. Part 5. The Gulf Between Stars. Leave the sun behind now. Turn your back on the last of its warmth, on the faint distant shell of comets, on the whole 2 light-year sphere that the star governs, and step out into the space between the stars. This is where distance stops being a large number and becomes something closer to a wall. Because the nearest star to our own, the closest sun in all the heavens, the first possible destination beyond our own system, is a small red dwarf called Proxima Centauri, and it lies about 4¼ light-years away. Let us translate that slowly, because the number in kilometres is one the mind simply refuses to hold. 4¼ light-years is about 40 trillion kilometres, not 40 billion, 40 trillion. To reach the nearest star, you would have to cross 40,000 billion kilometres of near-perfect nothing. And remember Voyager 1, our fastest ship, which after nearly 50 years has travelled a single light day. If we pointed Voyager at Proxima Centauri and let it fly, it would take about 70,000 years to arrive. 70,000 years. Our entire recorded history, every civilization that has ever risen and fallen, every war and every song and every name that has ever been written down, spans only a few thousand years. To cross the gap to the single nearest star, at the speed of our fastest machine, would take more than 10 times the length of all human history so far. A child launched aboard that ship would be dust, and their descendants would be dust, and their descendants' descendants across 2,000 generations would be dust, and still the ship would not have arrived. This is the fear of the interstellar gulf, and it is a fear unlike the ones that came before. The vacuum could kill you in seconds, but at least it was near. The moon was deadly, but at least it was reachable. The emptiness of the solar system was wide, but the sun still held it together. Out here, between the stars, there is no such comfort. The distances are simply too great for us. Not too great for our current technology, not too great for this century or the next, but too great for the human scale itself. A human life is far too short. A human civilization is far too short. Even a human species in the span it has so far existed is far too short to cross even one of these gaps. The distances between the stars are not an engineering problem waiting to be solved. They are built to a scale that does not include us, a scale on which a whole species is less than a single step, and that indifference to our time scale is its own kind of terror. And the space you would cross to get there is emptier than anything we have yet described. Inside the solar system at least there were planets and comets and the sun's warm light. Between the stars there is almost nothing at all. The average distance between star systems in our part of the galaxy is measured in light years, in trillions of kilometres, and in all that space there is little more than a few scattered atoms of hydrogen, drifting per cubic centimetre, colder and thinner than the finest vacuum we can make in a laboratory. If you were placed at a random point between the stars, you would find yourself in a darkness so complete and a solitude so total that the nearest star in any direction would be a distant, unreachable spark, years of light away, and everything else would be simply black. This is the true condition of most of the universe. Not planets, not stars, not light, but immense reaches of cold and empty dark, with the bright things floating rare and far apart, like a handful of embers scattered across an ocean. There is a kind of world that lives in this dark, and it is perhaps the loneliest object the galaxy contains. When planetary systems form, they are often violent places, and sometimes a young world is thrown clear of its star entirely, flung out by the gravity of a larger neighbour into the space between the suns. These are the rogue planets, worlds with no star of their own, and there may be billions of them adrift in our galaxy, possibly even outnumbering the stars themselves. A rogue planet does not orbit anything. It simply falls forever through the darkness between the stars, carrying no light and no warmth, its surface only a few degrees above the coldest temperature that physics allows. Let yourself stand on one for a moment. Let yourself feel what such a place would be. You're standing on the surface of a world that has no sun. Beneath your feet is solid ground, real rock, a planet as substantial and ancient as the Earth, with mountains and plains and frozen seas. But there is no light. Above you there is no sun, and there never has been, and there never will be. The sky is not the black of night with a sun waiting to rise. It is a black that no dawn will ever break, a permanent and total darkness that has held this world for longer than the Earth has existed. You look up, and where you long for a moon or a sunrise, there are only the distant stars, thin and cold and unimaginably far, each one trillions of kilometres away, none of them close enough to warm a single stone. The ground beneath you is colder than anything on Earth has ever been, hovering just above absolute zero, so cold the very air of any world would fall as snow and then freeze harder still. Nothing moves. Nothing has ever moved here but the slow fall of the planet through the dark. There is no wind, no sound, no warmth, no change, no hope of change. This world has been falling through the night between the stars for billions of years, and it will go on falling for billions more, and in all that time no light will ever touch it, and it will never once know that anything else exists. This is a darkness that is not waiting to end. This is a darkness that is simply what the universe is, almost everywhere, almost always. Now step back off that frozen world and return to the warm one you came from, and consider how fortunate, how improbable, how vanishingly rare it is to stand on a planet that has a sun at all. We are so used to daylight that we treat it as the natural order of things. But the natural order, across most of the galaxy, is the rogue planet's order. The natural order is the cold and the dark and the endless falling. The worlds with suns, the worlds with warmth and light, and the possibility of anything happening at all are the exceptions, and they float in a sea of frozen wanderers and empty light years that would swallow them without noticing. There is one more turn of the screw here, and it concerns not just the distance, but what the distance does to our loneliness. Because the interstellar gulf does not only make it hard to travel between the stars, it makes it hard even to reach out to them, to call, to be answered. A signal sent to the nearest star would take 4¼ years to arrive, and any answer would take 4¼ years to return. A single exchange, hello and hello back, would consume the better part of a decade, and the nearest star is only the beginning. Most of the stars in the galaxy are hundreds or thousands of light years away, which means any conversation with them, if there were anyone there to speak, would span centuries or millennia, one word per lifetime, the question asked by an ancestor and the answer received by a descendant who never knew them. The gulf between the stars is not just a barrier to our ships, it is a barrier to connection itself, a distance so wide that it isolates every point of light from every other, and turns the whole glittering galaxy into a scattering of islands, too far apart to ever truly touch. It is worth naming the neighbours, because even our closest stellar company is a lesson in distance. Proxima Centauri is the nearest, at 4¼ light years, and it belongs to a small group of 3 stars, the Alpha Centauri system, bound loosely together. After that, the next nearest stars are Barnard's star at about 6 light years, and then a scattering of others at 8, 9, 10 light years and beyond, each one a separate island of light with immense gulfs of nothing between them. Within about 10 light years of the Sun, a sphere that sounds small until you remember that a single light year is 40,000 billion kilometres, there are only a handful of star systems, perhaps a dozen. That is the true population density of our region of the galaxy. A dozen suns in a sphere 10 light years across, and between them, near perfect emptiness. We live not in a crowded city of stars, but in a thinly settled frontier where the nearest neighbour is an impossible distance away, and the ones beyond that are farther still. People have tried to imagine how we might ever cross such a gap, and the ideas themselves reveal the scale of the problem. The most discussed is the generation ship, a vessel so large and self-sustaining that it could carry a whole community across the void, with the travellers who arrive being the distant descendants of the ones who departed, generations having lived and died aboard during the centuries or millennia of the crossing. Think about what that requires. It requires building a world, a closed and perfect world that never fails, that recycles every breath of air and every drop of water flawlessly for hundreds of years, that raises generation after generation of people who will never see the world their ancestors left and will never see the world their descendants might reach, who will live their entire lives in the dark between the stars, in transit, belonging to no world at all. And even that staggering feat would deliver its passengers to only the single nearest star. The gulf is not just a distance. It is a distance so large that crossing it would require us to become a different kind of creature, one that measures its journeys in the lifetimes of civilizations rather than the lifetimes of people. There is a greater stillness to the interstellar dark that is worth feeling before we rise above it. Between the stars, the temperature of space itself, the background against which everything sits, is only about 3 degrees above absolute zero, the coldest temperature that can exist. That faint warmth is the last fading heat of the beginning of the universe, the afterglow of the moment of creation, cooled now over 13 billion years to almost nothing. Everywhere between the stars, in all that emptiness, this is the ambient condition, a near-total vacuum, a near-total dark, and a temperature within a few degrees of the absolute floor of cold. The rogue planets fall through it, and the light of distant stars crosses it, and it goes on, filling almost the entire volume of the galaxy, the true and ordinary state of nearly everything that exists. And yet the galaxy is glittering. For all this emptiness, when you pull far enough back, the stars do gather into something, a great wheeling structure of light that contains our Sun and Proxima Centauri and 100 billion others. We have been talking as though the stars were scattered at random through the dark, and locally that is nearly true. But on a larger scale they are bound together, held by gravity into an enormous spinning system, and when we rise high enough to see the whole of it, the loneliness does not go away. It only grows, because we discover just how many of these isolated suns there are, and just how small our own has become among them. The next threshold takes us up and out until the entire solar system, Proxima and all, collapses to a single point, and we see for the first time the wheel of 100 billion suns that we have been living inside the whole time without ever seeing its shape. Part 6. The Wheel of 100 Billion Suns. Rise now until the sun itself becomes a single point of light, and turn to look at the structure it belongs to. Our star, with its planets and its comets, and its 2 light-year sphere of influence, is one member of an enormous spinning city of stars called the Milky Way, and to see the whole of it you must pull back to a scale that makes the interstellar distances we just crossed look small. The Milky Way is a flattened spiral, a disk of stars turning slowly in the dark, and it is somewhere between 100,000 and 120,000 light-years across. Remember what a light-year is. Remember that the nearest star was 4 of them away, and that crossing even one would take our fastest ship 70,000 years. Now lay 100,000 of those distances end to end, and you have the width of the galaxy we live in. Inside that spinning disk there are, by most estimates, somewhere between 100 billion and 400 billion stars. The number is so large that it defeats every attempt to make it real. If you tried to count the stars of the Milky Way at a rate of 1 per second, never sleeping, never stopping, it would take you thousands of years just to reach the low estimate. Every one of those stars is a sun. Many of them have planets. Some of those planets are worlds like the frozen rogue we stood upon, and some, perhaps, are worlds with warmth and light and oceans. And all of them, all 100 billion or more, are bound together into this single, slowly turning wheel, of which our sun is one unremarkable member, sitting not at the centre, not anywhere important, but about 27,000 light-years out toward the edge, on one of the spiral arms, in a quiet suburb of the galaxy where nothing in particular is happening. Our sun is not still either. It is moving, as everything here is moving, carried around the centre of the galaxy in a great slow orbit. It travels at an enormous speed, hundreds of kilometres every second, and yet the galaxy is so large that even at that pace, a single orbit takes an almost unimaginable span of time. The Sun completes one lap around the Milky Way roughly every 225 to 230 million years. This span has a name. It is called a galactic year, and here is a fact to hold in the dark. The last time the Sun was in the position it now occupies, the last time a galactic year began, the dinosaurs had not yet come to rule the Earth. An entire age of giant reptiles rose, dominated the planet for over 100 million years, and vanished in a single catastrophe, all within one loop of the Sun around the galaxy. Our species, in its entire existence, has not moved the Sun even a fraction of 1 degree along that orbit. On the clock of the galaxy, everything human has happened in an instant too small to measure. At the very centre of this great wheel, 27,000 light-years from us, there is something that anchors the whole structure and that embodies, better than anything else, the strangeness of what we live inside. There sits a supermassive black hole called Sagittarius A star, with a mass about 4 million times that of our Sun. For most of history it was only inferred, its presence deduced from the way stars near the galactic centre whip around an invisible point at tremendous speed. But in 2022, a global network of telescopes working together managed to capture an actual image of it. A ring of light bent around a central darkness, the shadow of the monster at the centre of our galaxy. 4 million suns worth of matter, crushed into a region from which not even light can escape. Sitting at the centre of the wheel, we are all turning around. Every star in the Milky Way, including ours, dances slowly around that dark point at the centre, held in a great gravitational orbit by the presence of a thing that would erase any of them without a ripple. And now we come to the question that gives this threshold its particular weight, the question that turns the wonder of the galaxy into something colder. With 100 billion or more stars with untold billions of planets, many of them old enough and stable enough and warm enough that life could in principle have arisen on them, the galaxy should not be empty. If life is anything but a miracle that happened exactly once, then somewhere out there among those 100 billion suns, other minds should have come into being. And some of them should have done so long before us, because many of these stars are billions of years older than our Sun. Civilizations could have risen and flourished and reached across their own worlds, while the Earth was still a ball of molten rock, before there was a single living cell in our oceans. So where are they? We look and we listen and we find nothing. No signal, no structure, no unmistakable sign that anyone else is out there or ever was. And this silence forces us into a choice between two possibilities, and the terrible thing, the thing that makes this a moment to slow down and feel rather than simply to know, is that both of them are forms of loneliness. Consider the first possibility. Perhaps the galaxy is full. Perhaps life is common, and minds are common, and across those 100 billion suns there have risen countless civilizations, most of them long before us. And if that is true, then the silence means they are gone. It means the galaxy is not a garden but a graveyard, filled with the ruins of peoples who rose and thought and built and hoped, and who then, one by one, for reasons we cannot see, fell silent and vanished into the dark, leaving behind worlds we're too far away to visit and signals that faded before we ever learned to listen. A galaxy of tombs, of dead civilizations scattered across 100,000 light-years, each of them having once looked up at their own sky and wondered if they were alone, and each of them having received no answer because all the others were already gone. Now consider the second possibility. Perhaps the galaxy is empty. Perhaps life is so rare, so improbable, so nearly impossible, that it has happened only here, only once, only on our single small world in one quiet suburb of one ordinary galaxy. And if that is true, then we are alone in a way almost too large to grasp. Alone among 100 billion suns, alone across 100,000 light-years. The only mind, the only awareness, the only place in all that immensity where the universe has managed to become conscious of itself, surrounded on every side by hundreds of billions of stars that shine on no one, warm no one, are seen by no one, and mean nothing to anything, because there is no one out there for them to mean anything to. Sit with both of those, because there is no third option that is comforting. Either the galaxy is a graveyard full of the dead, or it is a wilderness of light with no one in it but us. 100 billion suns, and every possible answer to the question of who shares them is a form of solitude. That is the emotional truth at the centre of the galaxy, truer than the black hole, larger than the spinning wheel. We are either the last or the only, and we cannot yet tell which, and neither one is a comfort. There is a way to feel the size of the black hole at the centre that makes it more real than the raw number of 4 million suns. The stars that orbit closest to Sagittarius A star have been tracked for decades, and one of them swings around the central darkness on an orbit that brings it, at its closest, screaming past at a few percent of the speed of light, whipped around the invisible point like a stone on a string. To move that fast, to be flung around that hard, the thing at the centre must be almost unimaginably heavy and almost unimaginably compact. 4 million times the mass of our Sun packed into a region smaller than the orbit of Mercury. And every star in the galaxy, including ours, is in orbit around that centre, all of us turning slowly around the dark core of the Milky Way, held by its gravity, carried in the great galactic year that takes longer than the reign of the dinosaurs to complete a single loop. We do not feel it. We have no sensation of the enormous speed at which our Sun travels around the galactic centre, hundreds of kilometres every second, because everything around us moves with us, and the galaxy is so large that even that tremendous velocity seems to change nothing. We are being flung around a black hole at this very moment, and it feels like sitting still. The stars of the galaxy are not spread evenly through it either. They gather into the great spiral arms, long bright lanes where the gas is dense and new stars are constantly being born, and between the arms lie quieter, dimmer regions with fewer stars. Our Sun sits in a relatively calm spot, on the inner edge of a minor arm, in a region that has been stable and quiet for a very long time, and there is reason to think that this quiet is part of why we are here at all. The busy hearts of the spiral arms and the crowded core near the black hole are places of intense radiation, of exploding stars and violent bursts of energy that would make the long, slow, undisturbed development of life extraordinarily difficult. We may exist in part because we happen to occupy one of the calmer, safer neighbourhoods of the galaxy, a quiet suburb far from the dangerous centre, where a small warm world could be left alone long enough for something to wake up on it. The galaxy is not uniformly hospitable. Most of it, near the core, near the arms, near the frequent supernovae, would sterilize a world before life could take hold. The safe places are the margins, the quiet edges, the overlooked corners, and that is exactly where we find ourselves. Around the main disk of the galaxy there are also the globular clusters, ancient tight-packed balls of hundreds of thousands of stars, some of the oldest objects in the universe, orbiting the Milky Way like a swarm of grey moths around a lamp. A world inside one of those clusters would have a night sky unlike anything we can imagine, crowded with thousands of stars bright enough to read by. The nearest of them far closer than Proxima is to us. And yet even there, packed as densely as stars ever get, the distances between them would still be measured in light months and light years, still far too great for anyone to cross. Even in the most crowded place the galaxy offers, the stars remain islands, and the dark between them remains the rule. And still we have not reached the true scale of things, because as immense as the galaxy is, as impossible as its distances are, as lonely as its silence feels, the Milky Way is not the universe. It is not even a large part of the universe. It is a single wheel of light among an almost limitless number of others, and when we rise one threshold higher and look at the galaxy from the outside, it shrinks, as everything in this journey shrinks, until our entire 100 billion star home becomes one faint smudge among a multitude too great to count. What we have been calling immense is about to become a speck. Part 7. 1 grain among 2 trillion. Let the pace slow here for a while. We have been climbing through fear after fear, and the next thresholds will ask a great deal of you, so let this one be gentler, a place to rest and simply drift among the scale of things before we go on. Rise up out of the Milky Way, out through the spiral arms, up past the last stragglers of stars at the galaxy's edge, until the whole 100 billion star wheel lies below you, turning slowly, a single luminous disk in the dark. From here it looks almost delicate, almost peaceful, a soft spiral of light that you could cover with an outstretched hand. Everything we have talked about so far, every distance that broke the mind, the 70,000-year crossing to the nearest star, the 100,000 light-year width of the galaxy, all of it is contained in that one quiet spiral beneath you. And now, watch what happens as we keep rising. The Milky Way is not alone. It has companions, other galaxies bound to it by gravity, drifting through the same region of space. The largest of these is the Great Spiral of Andromeda, a galaxy much like our own but somewhat larger, lying about 2.5 million light-years away. That number, 2.5 million light-years, is worth pausing on gently, because Andromeda is the most distant thing that a human being can see with the naked eye. On a clear dark night, far from any city, you can look toward the constellation of Andromeda and find a faint smudge of light, no brighter than a breath on cold glass, and that smudge is an entire galaxy of 1 trillion stars, and the light entering your eye left it 2.5 million years ago, before our own species existed. When that light began its journey across the dark, there were no humans on Earth to receive it. It has been travelling all this time, crossing 2.5 million light-years of emptiness, to arrive at last tonight on the surface of your open eye. And here again is the old truth, softened now into something almost tender. You are always looking at something that is already gone, or at least at something as it was in a past so distant that the creatures who might one day see it had not yet been born. Our galaxy and Andromeda, together with a scattering of around 80 smaller galaxies, form a small cluster called the Local Group, and it spans about 10 million light-years. That is our neighbourhood, our immediate family of galaxies, held loosely together by gravity in one small pocket of the universe. But the Local Group is itself only a minor member of something far larger. Gather up thousands of galaxies, group them into clusters, and gather the clusters together in turn, and you arrive at a structure called a supercluster. Our own supercluster is named Laniakea, a word from the Hawaiian language meaning immense heaven, and it is about 520 million light-years across, and it contains something like 100,000 galaxies, all of them drifting slowly toward a common gravitational centre, all of them part of one connected flow of light and matter through the dark. Our galaxy, with its 100 billion suns, is a single thread in that immense weave, one bright filament among 100,000, being carried along in a river of galaxies too large to picture. And Laniakea is not the whole of it either. Superclusters like ours are themselves only pieces of a still greater pattern, and when we rise high enough to see the larger scale of all, we find that the entire observable universe contains an estimated 2 trillion galaxies. 2 trillion. Not 2 trillion stars, but 2 trillion galaxies, each one an island of 100 billion or more suns. Take everything we have crossed, the whole enormous journey from the line above your head to the wheel of the Milky Way, all of it, the planets and the stars and the interstellar gulfs and the galactic year and the black hole at the centre of it all, and understand that the entire Milky Way is 1/2 trillionth of what we can see, and we cannot even see most of what exists. There is no fear I need to press upon you in this passage. This is simply the scale, laid out gently, for you to feel rather than to fear. Let it settle over you the way a large, quiet fact settles over the mind late at night. You're a single person, on a single world, orbiting a single star, one among a few 100 billion in a single galaxy, which is one among a few 100 billion in a single supercluster, which is one among a great many in a universe that holds 2 trillion galaxies. Each step up that ladder multiplies the one before it by a factor the mind cannot really hold. And at every level, the structure is the same, a few bright things, unimaginably far apart, floating in an overwhelming amount of dark. The universe is built out of the same lonely pattern, repeated at every scale, from the emptiness between the planets to the emptiness between the galaxies, the same near-total darkness with rare islands of light scattered thinly through it. There is a strange comfort available here, if you want it, and it is worth naming before we descend again into fear. It is this. Every single one of those 2 trillion galaxies is, from the inside, exactly like ours. Every one of them, if there is anyone there to look, would seem to its inhabitants like the whole of everything, the centre of all things, the natural and obvious middle of the universe. Our sense that we are somewhere important, somewhere central, somewhere that matters, is not a fact about the cosmos. It is a feeling that every possible observer, anywhere in those 2 trillion galaxies, would share. There is no centre. There is no edge that anyone stands at. Everywhere is the middle of an immensity, and everywhere feels from the inside like home. In a universe with no centre, the place where you happen to be is as good a centre as any, and the small warm world you come from is, from where you stand, genuinely the middle of everything you will ever see. Hold that thought a moment longer, because it is the last gentle thing this journey has to offer for a while. Rest in the scale. Let the numbers stop being frightening and become, just for now, simply large, the way the ocean is large, or the night is large, in a way that can hold you rather than crush you. 2 trillion galaxies, 100 billion suns in each, and you, here, awake, able to know it. There is a version of this fact that is terrifying, and we will return to it soon enough. But there is also this version, the calm one, the one where the immensity is not a threat, but simply the true and quiet size of the thing you are a part of, the size of the house you were born into. Let the imagination rest on the cosmic web for a moment, because it is one of the few sights in all of this that is genuinely, quietly lovely. If you could pull back far enough to see the universe on its larger scale, and if you could see the way the galaxies are arranged, you would find that they are not scattered at random, but strung along enormous glowing threads. Filaments of galaxies hundreds of millions of light-years long, joined together at bright knots and crossings, with immense dark hollows between them. Astronomers who map the positions of galaxies across the sky see this structure emerge from the data, and it looks, more than anything, like a network of fine threads, a lattice of light running through the dark, the largest pattern that exists. Our galaxy sits on one of those threads, part of the weave, carried along in the slow drift of everything toward everything else. There is something almost restful in knowing that even at the larger scale the universe has a shape, an architecture, a structure that connects our small bright home to the whole of the luminous web. Our local group has more members than just the Milky Way and Andromeda, and they are worth picturing, because they fill in the shape of home. There is the Triangulum galaxy, a smaller spiral, the third largest member, faintly visible on a very dark night to a sharp eye. There are the 2 Magellanic Clouds, ragged little galaxies that orbit the Milky Way and hang in the southern sky like torn scraps of the band of the galaxy itself, visible to the unaided eye from the southern hemisphere as soft glowing patches. And there are dozens of small dim dwarf galaxies, faint scatterings of stars orbiting the 2 great spirals, most of them so dim that we have only found them in recent decades, some of them still being discovered. This is the family, the 80 or so galaxies bound together across 10 million light-years, drifting through the same small pocket of the cosmos, held together by gravity while the rest of the universe expands away around them. It is a quiet neighborhood, and for the moment it is stable, and everything in it will stay together even as the wider universe recedes. There is a slow and gentle motion running through all of it, and understanding it is part of resting in the scale. The galaxies beyond our local group are moving away from us, carried by the expansion of space, and we can measure how fast by the way their light is stretched toward the red end of the spectrum as it travels, the light itself lengthened by the swelling of the space it crosses. The farther a galaxy is, the faster it recedes, and the more its light is reddened, so that the most distant galaxies we can see are shifted so far toward the red that their light has been stretched out of the visible range entirely into the infrared, and only our most sensitive instruments can find them at all. When we look at the far sky, we are watching this expansion written directly into the colour of the light, every distant galaxy quietly reddened by its retreat, the whole universe gently sliding away from us at a rate we can read in the stretching of its glow. It is not a violent motion. It is slow and smooth and silent, the unhurried drift of everything away from everything, and for now, tonight, it is far enough from finished that the sky is still full. The name our supercluster carries is worth sitting with too, because whoever chose it understood something. Laniakea, immense heaven, from the language of a people who navigated the largest ocean on Earth by the stars, who crossed thousands of kilometres of open water in small boats guided only by the sky. There is a fittingness in a seafaring people's word being given to the ocean of galaxies we drift within, because that is what it is, an ocean, and we are on it in a small boat, guided by the light of things unimaginably far away, most of which we will never reach. The people who named the currents of the Pacific by watching the stars would perhaps have understood, better than most, what it means to be a tiny vessel on an immensity, reading a sky for signs of a shore you may never find. And here is the fact that makes the 2 trillion galaxies bearable rather than crushing if you let it. Every one of those galaxies is made of the same things ours is made of, the same handful of elements, forged in the same kinds of stars, obeying the same laws, glowing with the same light. The universe is not a chaos of infinitely different places. It is the same few ingredients, the same physics, the same patterns, repeated at every scale and in every direction, so that a galaxy 10 billion light-years away is built of the same atoms as the chair you're sitting in and the body you're sitting in it with. You're made of the same material as the farthest thing you can see. The immensity is not alien to you. It is your own substance spread out across a distance too large to picture, and you are the part of it that came together, briefly, into something that could look at the rest and recognize itself. Because when we move on from here, the calm ends. So far, everywhere we have looked, there has at least been something, stars and galaxies and light, however far apart. The next threshold takes us to the places where there is not. It takes us to the enormous emptinesses between the great structures, the regions where the galaxies thin out and vanish, and there is simply nothing for hundreds of millions of light-years in every direction. And in one of those emptinesses we will find the most quietly frightening fact in this entire descent, which is that a place can be so empty that it lies to the ones who live there and convinces them, wrongly, with perfect logic, that they are utterly alone. Part 8. The places where nothing is. When you pull back far enough to see the universe on its larger scale, you discover that the galaxies are not scattered evenly through space. They are arranged into a pattern, and the pattern is unlike anything our intuition would predict. The galaxies gather along immense threads and sheets, long luminous filaments and walls that stretch across hundreds of millions of light-years, and these filaments join and cross at great knots, where clusters and superclusters pile up. Astronomers call this arrangement the cosmic web, and from a distance it looks almost biological, like the branching of neurons or the structure of a sponge, a network of glowing strands running through the dark. But the strands are the exception. The strands are where all the galaxies are crowded, and between them lies the thing this threshold is about. Between the filaments of the cosmic web there are enormous, nearly empty regions, and they are called voids. A void is not empty in the way the space between two stars is empty, or even the way the space between two galaxies is empty. A void is empty on a scale that dwarfs all of those. These are regions hundreds of millions of light-years across in which there is almost nothing at all, no galaxies, or only a scattered handful where there should be thousands. And here is the fact that should stop you cold. These voids are not the exceptions in the universe. By volume, they are most of it. The great majority of the universe is not stars and not galaxies, and not the bright filaments of the cosmic web. The great majority of the universe is void, is emptiness, is the immense dark nothing between the threads. The light we see, all of it, every galaxy and every star is crowded into a thin bright web that threads through an ocean of emptiness so large it makes the web look like an afterthought. There is one void in particular that carries a lesson we cannot ignore, and it was found in 1981 by astronomers surveying a patch of sky in the direction of the constellation Boötes. What they discovered there has come to be called the Boötes Void, and it is one of the largest empty regions we know. It is roughly 330 million light-years across. Think about what that means against everything we have built up. The nearest star was 4 light-years away. The galaxy was 100,000 light-years across. Andromeda was 2.5 million light-years away. And here is a hole in the universe more than 300 million light-years wide, a bubble of near-perfect nothing so large that you could fit the entire distance to Andromeda inside it, more than 100 times over. Inside that immense volume, where the ordinary density of the universe would lead us to expect many thousands of galaxies, we have found only about 60 galaxies, scattered through a region so large that they are almost unaware of one another, each one alone in a darkness hundreds of millions of light-years across. An astronomer who first studied the region remarked that if the Milky Way had been located in the centre of the Boötes Void, we would not have known there were other galaxies until the 1960s. Let that sink in. If our galaxy sat at the centre of that void, then through all of human history, through every civilization that ever looked up, through the invention of the telescope and centuries of careful astronomy, we would have looked out into the night and seen our own stars, and beyond them, nothing. We would have concluded with perfect reason, using the best evidence available, that the Milky Way was the whole of creation, that we were alone, that beyond our own island of stars there was simply empty dark forever. And we would have been wrong. The galaxies would have been there all along, thousands upon thousands of them, simply too far beyond the edge of the void for us to see. This is the most quietly terrifying idea in the entire descent, and it is worth stating as plainly as it can be stated. The emptiness can lie. A place can be so empty that it deceives the minds that live within it and convinces them, through no error of their own, through careful and honest reasoning, that nothing else exists. Absence of evidence, we are so often told, is not evidence of absence, and the Buddha's void is the universe's own proof of that warning, written across 300 million light-years. There are locations in this cosmos from which the honest, rational, evidence-based conclusion is that you are alone in the universe, and that conclusion is false. The universe does not merely contain emptiness. It contains emptiness large enough to fool a civilization about the fundamental nature of reality. Come down into one of these places now. Let yourself stand at the very center of a void and feel what it would be to look out from there. You're standing at the center of the Buddha's void, and you are turning slowly, looking for a neighbor. Above you and below you, and on every side there is the night sky, and it is not like the sky you know. The sky you grew up under is crowded, thick with stars, and beyond them, if you knew where to look, the faint smudges of other galaxies. This sky is nearly bare. You turn, and there is dark. You turn again, and there is dark. Here and there, impossibly far apart, a single faint point of light, so distant and so alone that it takes you a long moment to be sure it is really there. You keep turning, and the darkness between those few scattered lights is not the friendly darkness of a familiar night. It is a darkness that goes on and on, hundreds of millions of light-years in every direction, with almost nothing in it at all. And you understand, standing there, that if you had been born here, if your whole species had risen on a world in this place, you would look up every night at this nearly empty sky, and you would reason, carefully and correctly given what you could see, that the universe was small and dark and yours alone. You would build your entire understanding of everything on the evidence of an emptiness that was lying to you. The darkness here has stopped being merely empty. It has become a presence, an active thing, a silence so complete that it reaches into the minds of the ones who live inside it, and quietly rewrites what they believe is true. Step back from the center of the void, and hold what it taught you, because it changes the meaning of everything we have said about being alone. When we stood in the galaxy and asked whether it was a graveyard or a garden, we assumed that our failure to find anyone meant something, that the silence carried information. The void teaches us that silence can be a liar. It teaches us that the absence of a signal, the emptiness of a sky, the failure to find any neighbor, may be not the truth about the universe, but merely the truth about where we happen to stand. We do not know whether our own corner of the cosmos is a crowded filament or a lonely edge of some greater emptiness. We do not know whether the quiet we hear is the quiet of a universe that is truly empty, or only the quiet of a place from which the others cannot be seen. The void does not answer that question. It only tells us coldly that we cannot trust the emptiness to tell us the truth. The Buddha's void is the most famous, but it is far from the only one, and it may not even be the one that matters most to us. Astronomers studying our own region of the universe have found evidence that the Milky Way itself sits within a larger-than-average empty region, sometimes called the local void or, in one study, a great underdensity many hundreds of millions of light-years across. If that is correct, then we do not live in a crowded part of the cosmos at all. We live near the edge of one of the emptier regions, a place where the galaxies are thinner on the ground than the cosmic average, which would mean that our own view of the universe is already, subtly, a view shaped by emptiness. The lesson of the Buddha's void, that where you stand determines how full the universe looks, may apply more directly to us than we would like. We may be, in a smaller way, already partway toward the deceived position, already living in a place quieter and emptier than the universe as a whole, already receiving a slightly misleading report about how crowded creation really is. Consider what a single galaxy inside a great void endures. The 60 or so galaxies scattered through the Buddha's void are not clustered together for company. They are spread so thinly through that enormous volume that each one is effectively alone, its nearest neighbor tens of millions of light-years away, far beyond the reach of any casual glance. A galaxy in the center of that void, if it held a world with watchers on it, would drift through its existence in near total isolation, its inhabitants looking out at a sky almost bare of other galaxies, with no bright neighbors to reveal that the universe was full. These are the loneliest galaxies that exist, marooned in the emptiest places, and there are worlds within them, almost certainly, turning under skies that tell them, falsely, that they are the only light there is. The void does not just contain emptiness, It contains isolated islands of stars, each one a potential home, each one cut off from the rest of creation by an emptiness so wide it functions as a wall. There is a temptation, faced with the voids, to look for meaning in them, to ask whether the emptiness is arranged, whether it means something that we find ourselves where we do. It is worth being honest here, in the way this channel tries always to be honest. The voids are not designed. They are the natural result of the way matter has clumped together under gravity over billions of years, the dense regions pulling material inward and growing denser, the sparse regions giving up their matter and growing emptier, until the universe sorted itself into web and void. There is no intention in it. But the feeling the voids produce, the sense of an emptiness so large it could isolate and deceive a whole civilization, is real, and it is a feeling worth trusting even when the mechanism behind it is blind. The universe was not built to make us feel alone. It simply, in the ordinary course of its physics, produced emptinesses large enough to do exactly that, whether anyone was meant to feel it or not. And there is a further turn, because the voids are not static. The universe is expanding, and the expansion pulls hardest in the empty regions, so the voids are growing, slowly stretching wider, pushing their few lonely galaxies farther and farther apart as time goes on. The emptiness is not only immense, it is winning. Across the larger scales, the bright web of galaxies is being stretched thinner, and the dark between the threads is opening wider, and the long trend of the universe is toward more emptiness, more distance, more dark. Which brings us to the edge of what we can even see, and to a fear larger than the void, because up to now everything we have described has at least been out there, real, present, part of the universe we belong to. The next threshold takes us to the boundary beyond which nothing can reach us at all, and shows us that the light we see from the farthest reaches is not a window onto what is there now, but a message from things that, in many cases, are already gone. Part 9. The light that is already dead. We come now to the edge of everything we can see, and to understand what waits there, we have to return one last time to the idea we first met on the moon, the idea that has followed us like a shadow through this whole descent. When you look out into space, you're always looking at something that is already gone. At the moon, the delay was barely more than a second. At the Sun, it was 8 minutes. At Andromeda, it was 2.5 million years. And as we push out toward the farthest reaches of what our telescopes can detect, that delay grows until it swallows almost the entire age of the universe. The observable universe is about 93 billion light-years across. That number should stop you, because the universe is only about 13.8 billion years old. How can we see things 93 billion light-years away, if light has only had 13.8 billion years to travel? The answer is that space itself has been expanding the whole time. The light left its source long ago, when that source was much closer, and as the light travelled, the space it was crossing stretched, carrying the source ever farther away even as the light made its slow way toward us. So we can see objects whose light took 13 billion years to arrive, but which are now, because of all that stretching, far more than 13 billion light-years distant. The universe we observe is a sphere 93 billion light-years wide, and every part of it that we see in the past. That last point is the one to hold, because it transforms the night sky from a picture into a haunting. The sky is not a snapshot of the universe as it is. It is a collage of moments, each point of light showing a different age, none of them the present. The sun as it was 8 minutes ago, the nearest stars as they were years ago, Andromeda as it was before humans existed, and the faintest, most distant galaxies our great telescopes can find, appearing to us as they were more than 13 billion years ago when the universe was young and they were newly formed. We are not seeing those galaxies. We are seeing their infancy, their light released when they were young, a message that has been crossing the expanding dark for almost the whole history of the cosmos, and in the billions of years since that light departed, those galaxies have lived their lives, formed their stars, spun through countless rotations, changed utterly, and in many cases the objects as they were when that light left them no longer exist in any recognizable form. The sky is full of ghosts. Every long exposure image we take of the distant universe is a photograph of the dead, of things that were, of light outliving its source across spans of time longer than the Earth has existed. Now add the cruelest part, the part that turns this from a strange fact into a form of grief. The expansion of the universe is not merely continuing, it is accelerating. The galaxies are not just moving apart, they are moving apart faster and faster as time goes on, driven by something we call dark energy that pushes space itself to stretch at an ever-increasing rate. And because of that acceleration, there is a boundary around us, a cosmic horizon, beyond which the space between us and everything else is expanding faster than light can cross it. Anything past that boundary is not merely far away, it is unreachable, forever, in the strongest sense the word can carry. No ship we could ever build, no signal we could ever send, not even light itself, launched today with everything we have, could ever cross the growing gap to reach it. It is gone from us, walled away by the expansion of space, sealed off behind a horizon we cannot pass. And here is the number that should make you go still. Of all the galaxies we can currently see, all the countless islands of light spread across that 93 billion light-year sphere, somewhere between 94 and 97% of them are already beyond that horizon, already unreachable, already, in every way that matters, lost to us. We can see them, because their old light is still arriving, the light they sent long ago when they were closer. But we could never go to them, and we could never signal them, and nothing we do could ever touch them, because the space between us and them is opening faster than anything can cross it. The overwhelming majority of the universe we can observe is a universe we can only ever watch, never reach, a gallery of light from places that have already been carried permanently out of our grasp. This is worth feeling, not just knowing, so let yourself feel it. Right now, silently, without any drama, galaxies are crossing that horizon. At this very moment as you listen, the accelerating expansion of the universe is carrying more and more of the cosmos out beyond the boundary of what we could ever reach. The universe that is accessible to us, the part we could in principle ever travel to or communicate with, is shrinking quietly, continuously, a little smaller with every passing second. It is not that the universe is simply large and far away. It is that the universe is leaving. It is receding from us on every side, faster and faster, taking almost everything with it, and there is nothing we can do, and nothing anyone could ever do, to hold on to a single galaxy of it. We are watching the largest thing there is slip away, and it does not slow, and it does not stop, and it will never, ever come back. Remember the phrase from the beginning, the one about the black sky above the space station. Above the blue, it is always night. It meant then a small and local thing, that just above our thin shell of air, the darkness of space is always present, waiting behind the daylight. But now the phrase has grown to hold the whole universe. The blue has become everything we can reach, the small bright sphere of the accessible cosmos, and the night beyond it has become the true and permanent dark of everything the horizon has already taken, everything that has crossed beyond return, the 94% and more that we can see but never touch. Above the blue, it is always night. Around the small warm circle of everything we could ever reach, there is a darkness we can never cross into, and it is closing in, and the circle is growing smaller, and the night is winning. There is a grief in this that is different from every fear that came before. The vacuum could kill you, but it was near. The distances could isolate you, but the things they isolated you from were still there. Here, for the first time, the loss is total and permanent and already accomplished. The universe is not threatening us. It is leaving us, the way the tide goes out and does not return, the way a train pulls away from a platform carrying everyone you have ever loved, slowly at first and then faster, until it is a point on the horizon, and then nothing at all. We were born a little too late to hold on to the universe, and a little too early to have forgotten it was ever there. We can still see what we are losing. That is the particular cruelty of this moment in cosmic time. We can still see it, all of it, the 2 trillion galaxies, the great luminous web, and we can watch it go. It is worth knowing how recently we learned this, because it changes how we hold it. For most of the 20th century, astronomers assumed that the expansion of the universe, which had been discovered in the 1920s, must be slowing down, gradually braked by the gravity of all the matter pulling inward. It seemed obvious. Gravity attracts. The galaxies should be dragging on one another. The expansion should be losing speed. Then, in 1998, 2 teams of astronomers measuring the light of distant exploding stars found the opposite. The expansion was not slowing, it was speeding up. Something was pushing the universe apart faster and faster, overwhelming the inward pull of all its matter, and we had no idea what it was. We still do not really. We call it dark energy, which is less an explanation than a name for our ignorance, a label on a force that makes up most of the energy of the universe, and whose nature remains one of the largest unsolved problems in all of science. The thing that is carrying the cosmos away from us, sealing the galaxies beyond our reach, is something we discovered less than a single human lifetime ago, and still do not understand. There is one light that reaches us from farther back than any galaxy, and it is worth naming because it is the thing the future will lose first. Coming from every direction in the sky, faint and cold, there is a glow left over from the earliest moment the universe became transparent, a little under 400,000 years after the beginning. It is called the cosmic microwave background, and it is the oldest light there is, the afterglow of creation itself, stretched by the expansion of the universe into a whisper of radiation that fills all of space. From that ancient light we have learned almost everything we know about how the universe began and what it is made of. And that light too is fading, stretched thinner and colder by the same expansion, so that the far future astronomers we imagined will not be able to detect it at all. The single most important piece of evidence about the origin of everything, the baby picture of the cosmos, will slip below the threshold of detectability, and with it will go the last proof that there was ever a beginning to lose. We are, in a strange and specific sense, lucky to be early. We live in a chapter of the universe when the galaxies are still visible, when the ancient light still reaches us, when the evidence of the great expansion is still written plainly across the sky for anyone who learns to read it. A civilization arising too late will find none of this. They will look out at a dark and empty sky, see only their own stars, and conclude that the universe is small and quiet and eternal, and they will have no way to know how wrong they are because everything that could correct them will have receded beyond the horizon or faded below detection. We happen to exist in the narrow window when the truth is still legible. That is a kind of fortune, and it is also a kind of grief, because to be able to see the universe clearly is also to be able to watch, in full understanding, as it begins the long process of vanishing. And it does not end with distance. If the expansion carries the universe away, then far enough into the future, there will come a time when the sky itself is emptied, when the galaxies beyond our own have all crossed the horizon and vanished from view, when the long exposure images we treasure could never be taken because there would be nothing left in them to photograph. The universe is not only leaving, it is heading toward a state in which it will have taken almost everything with it, and left behind a darkness so complete that the light we see tonight will one day be impossible to see at all. That is the final threshold, the last and coldest one, the end not of space but of time, and it is where we are going now. Part 10. The cold, quiet end, and the eye that watched. The deepest terror this journey has to offer is not a place, it is a time. It lies not at the edge of space but at the far end of the future, and to reach it we have to let go of distance altogether and travel instead down the long slope of years, past the age of our sun, past the age of the galaxy, into spans of time so enormous that the entire history of the universe up to now becomes a bright brief flicker at the very beginning. Because the universe is not only leaving us in space, it is running down in time, and the state it is running toward is the coldest and quietest thing there is. Begin with a consequence of everything we said at the last threshold. The galaxies are crossing the horizon, vanishing from reach, and eventually from view. Cosmologists have followed this trend forward and reached a conclusion that is genuinely difficult to hold in the mind. There will come a time, roughly 100 billion years from now, when a civilization living in what remains of our galaxy will look out at the night sky and see nothing beyond their own stars. All the other galaxies will have crossed the horizon and disappeared. The great luminous web will be gone from view, and those future astronomers, looking out with the best instruments they could build, would see only their own island of stars floating in an apparently endless and empty dark. They would have no way to know that the universe had ever been full of galaxies. They would have no way to detect the expansion, because there would be nothing left in the sky to watch receding. They would even lose the ability to see the faint afterglow of the universe's beginning, the ancient light that tells us today that there was a big bang at all. The evidence would be gone. The true history of the cosmos would have become unobservable, erased not by any catastrophe but simply by the passage of time and the stretching of space. Think about what that means for the idea of truth itself. those future beings would look at their small dark sky and reason carefully and conclude, exactly as the dwellers in the Bhuta's void would conclude, that they were alone, that their galaxy was the whole of creation, that the universe was small and static and quiet. And they would be wrong, and there would be no way for them to know it, because the universe would have hidden its own past from them. We are able to see the truth about the cosmos, the expansion, the galaxies, the beginning, only because we happen to live now, in this early and well-lit chapter, before the evidence has slipped away. We live in one of the last epochs from which the universe is still honest about what it is. That window is closing, and once again you are always looking at something that is already gone, except now the thing already gone is the visible history of everything, expiring quietly as the cosmos ages. Follow the slope down further, past that lonely 100-billion-year sky, and the lights begin to go out. Stars are not eternal. They burn through their fuel and die, and new stars form from the gas left behind, but that gas is finite, and it is being used up. There will come a time, on the order of 100 trillion years from now, when the last of the gas has been spent, when no new stars can form, and the stars that remain burn down one by one into embers. The bright era of the universe, the age of starlight, the only age in which worlds are warm and life is possible, is a brief early chapter that ends, and after it comes a long twilight of cooling remnants, dim red dwarfs fading, white husks of dead stars going cold and black, drifting through a darkening universe. And even those remnants do not last. Over spans of time so long that the numbers stop meaning anything, matter itself decays, and the black holes that are the last great structures left, the final monsters at the centres of dead galaxies, slowly evaporate, bleeding away their mass over spans as long as 10 to the 100th power years, until even they are gone, and there is nothing left but a thin, cold, ever-thinning haze of particles drifting through an endlessly expanding dark. This is how it ends. Not in fire, not in a great collapse, not in a crash, not in any dramatic and final catastrophe that at least would have the dignity of a climax. It ends in a slow running down, a gradual cooling, a fading of every light and a stilling of every motion, until the universe is a uniform, freezing, empty dark in which nothing ever happens again. The final state of everything is not an explosion but a silence. It is a darkness so complete and so permanent that the very memory of light becomes impossible, a cold that goes on without end, an emptiness that is not waiting for anything because there is nothing left that could ever come. The darkness that has followed us through this whole descent, growing from a mere absence into a presence, reaches here its final form. In the end, the darkness is all there is, and it is forever. Let yourself go there, once, to the very end, and stand in it. You're beside one of the last stars. It is a dim red ember, barely glowing. The final warmth in a region of space that has otherwise gone entirely dark. There are no other galaxies in the sky. There have been none for longer than you can conceive. There are only a few faint dying embers scattered impossibly far apart, and between them the total black of a universe that has spent itself. The star beside you flickers and cools, and its light grows fainter, and you understand that when it goes there will be nothing, no warmth anywhere, no light anywhere, no motion, no change, no event, in any direction, forever. This is the last of it, and in this final darkness, at the very end of all things, imagine that there is one point of awareness left, one last mind watching the last star die. And imagine that it understands what it is seeing. It knows that there was once a universe full of light. It knows that there were once 2 trillion galaxies, and 100 billion stars in each, and worlds with oceans and minds that looked up and wondered. It holds all of that at the very end, in the last moment before the dark becomes complete. And then the star goes out, and the knowing goes out with it, and the universe no longer contains anyone who remembers that it was ever anything but night. There is a reason the universe runs down in this direction and not the other, and it is one of the strangest facts in all of physics. Everything that happens, everything, tends toward disorder, toward the spreading out of energy, toward the smoothing of differences. Heat flows from hot things to cold things and never the reverse. A cup of coffee cools to match the room. The room never spontaneously gives its warmth back to the cup. This one-way tendency, this steady slide from order toward disorder, is what gives time its direction, what makes the past different from the future, what makes the arrow of time point the way it does. And the far future we have been describing, the cold and empty end, is simply what that slide looks like when it is followed all the way to its conclusion. The universe began in a state of exquisite order and low disorder, and it has been spending that order ever since, spreading its energy thinner and more even with every passing moment, and the heat death is the final state in which the spending is complete. The energy so evenly spread that no difference remains anywhere, no flow is possible, and nothing can ever happen again. Time itself, in a sense, would end, because with no change there is nothing left for time to measure. Some physicists have wondered whether even that final stillness is truly permanent, or whether, across spans of time so long they defy any notation, a chance fluctuation might briefly stir the dead universe back into a flicker of order, the way a shuffled deck might, given long enough, fall by accident into sequence. But such fluctuations, if they happen at all, would be almost infinitely rare and almost infinitely brief, isolated sparks in an ocean of dark that quickly return to the same uniform nothing. There is no real reprieve in them. The overwhelming condition of the far future is the cold and the dark and the stillness, stretching on without meaningful end, and whatever fleeting stirrings might interrupt it would be lost in it as instantly as a single spark is lost in an endless night. Now, come back, come all the way back, up the long slope of years, back through the dying stars and the emptying sky, back past the voids and the galaxies and the interstellar gulfs, back through the solar system and its lonely worlds, back to the moon, back through the thin blue shell of air, back to the surface of a small warm world where you're sitting, right now, awake, alive, listening. Come back, because there is one thing left to say, and it is the only thing in this whole descent that is not a fear. Everything we have travelled through is indifferent. That has been the quiet truth underneath every threshold. The vacuum does not hate you. It simply is not arranged to keep you alive. The distances do not exclude you out of cruelty. They are simply built to a scale that does not notice you. The voids do not lie to deceive. They are merely empty. The universe is not your enemy. It is something far stranger and, in a way, far lonelier than an enemy. It does not know you are here. It does not know it is beautiful, or terrible, or immense. It does not know it is anything at all. The stars do not know they shine. The galaxies do not know they turn. The whole enormous cosmos, in all its immensity and all its terror, is unaware of itself, a machine of light and gravity and dark running blind through the years, and it would have gone on exactly the same whether or not anyone had ever existed to see it. And yet someone does exist to see it. That is the turn, and it is the only consolation this subject allows, and it is enough. In all of that immensity, across all those thresholds, through the whole immense indifferent machine, there is a small warm world where matter has arranged itself into something that can look back. We are the part of the universe that woke up. We are the part that looks out at the immensity and the terror and the cold and, instead of merely enduring it as the rocks and the stars endure it, understands it. The universe does not know it is frightening. We are the ones who know. The universe cannot see itself. We are its eyes. Every fact in this whole descent, the thinness of the air, the boiling of the vacuum, the 70,000-year gulf to the nearest star, the graveyard of the galaxy, the lying void, the leaving sky, the cold and final dark, every one of them is known only because we are here to know it. The cosmos is enormous and does not care, and we are small, and we noticed anyway. That noticing, that single improbable fact that a corner of an indifferent universe has become aware of the whole, is not diminished by how small we are. It is made more astonishing by it. So the farther you travel into space, the more terrifying it gets, and that is true, and we have followed it all the way down to the end of time and found it true at every step. But there is a companion truth that only appears once you have gone the whole way and come back, and it is this. The same descent that makes the universe terrifying is the descent that makes a single conscious observer extraordinary. The darkness is real, and it is winning, and it is forever. But for now, in this brief and well-lit chapter, before the sky empties and the evidence slips away, there is something here that can hold all of it in mind at once, and be frightened, and be moved, and look up anyway. Perhaps that is the only answer the question ever had. The universe is not frightening because of what is out there. It is frightening because we are the wrong size to look at it safely, and we look anyway. And maybe the looking, the fact that we cannot help but look, is the bravest thing that has ever happened in all that immense and indifferent dark.